Hi everyone. Through this class, we are going to study about the definition of multiplexer, construction and working of 4 to 1 and 8 to 1 multiplexers. The multiplexer is a logic circuit that has several input data lines and a single output line. It consists of data select inputs that permits the selection of input digital data and route this data to signal output. The logic symbol of 4-input multiplexer is shown here. Here there are two data selection inputs S0 and S1 and the data inputs are D0, D1, D2 and D3. And here the data output is marked as this Y. If the data select inputs S1 and S0 are zeros, then the input D0 is selected and that is routed to the output. So output Y will be equal to D0. So if D0 is 0, then output will be 0 when S1 and S0 are zeros. If D0 is 1, output Y will be 1. If S1 is 0 and S0 1, then input data D1 is selected. If S1 is 1 and S0 is 0, D2 is selected. If S1 1 and S0 1, data input D3 is selected. The Boolean expression for data output Y of 4 to 1 multiplexer is Y equal to D0 S1 bar S0 bar or D1 S1 bar S0 or D2 S1 S0 bar or D3 S1 S0. We can realize 4 to 1 multiplexer using 4 AND gates and 1 OR gate like this. Here the data inputs are D0, D1, D2 and D3. Data select inputs are S1 and S0. We connect one NOT gate to this S0 input, then we get S1 bar. And we connect another NOT gate to this S0 input, then we get S0 bar. And here for the first term it is D0 S1 bar S0 bar. So for getting this we connect D0 to first AND gate, then S1 bar and S0 bar as the inputs for this first AND gate. Then we get the output as D0 S1 bar S0 bar. For the second AND gates the inputs are D1 then S1 bar and this S0. So here we get D1 S1 bar S0. And for the third AND gate, inputs are D2 S1 and S0 bar. So the output is D2 S1 S0 bar. For the fourth AND gate, inputs are D3 S1 and S0. So the output is D3 S1 S0. All the outputs of these 4 AND gates, they are connected as the inputs for the OR gate. So the output Y will be equal to D0 S1 bar S0 bar or D1 S1 bar S0 or D2 S1 S0 bar or D3 S1 S0. 8-input multiplexer or 8 to 1 multiplexer logic symbol is like this. Here there are 3 data select lines. They are S0, S1 and S2 and 8 input lines are there. They are D0, D1 up to this D7 and the data output is marked as Y. For 8-input multiplexer, when S2, S1 and S0 are 0, 0, 0, data input D0 is selected. When they are 0, 0, 1, D1 is selected. If S2, S1, S0 is 0, 1, 0, then D2 is selected. If it is 0, 1, 1, D3 is selected. 1, 0, 0, then D4 is selected. If it is 1, 0, 1, then D5 is selected. If S2, S1, S0 are 1, 1, 0, then D6 is selected. If it is 1, 1, 1, D7 is selected. The Boolean expression for 8 to 1 multiplexer is y equal to D0, S2 bar, S1 bar, S0 bar, or D1, S2 bar, S1 bar, S0, or D2, S2 bar, S1, S0 bar, or D3, S2 bar, S1, S0, or D4, S2, S1 bar, S0 bar, or D5, S2, S1 bar, S0, or D6 S2 S1 S0 bar, or D7 S2 S1 S0. We can realize this using 8 AND gates and an OR gate like this. Here there are 3 data select inputs S2, S1, S0. We connect one NOT gate to this S2, then we get S2 bar. Another NOT gate to S1, so here we get S1 bar. And another NOT gate to this S0. So here we get S0 bar. Then for the first AND gate, inputs are D0, S2 bar, S1 bar and S0 bar. For the second AND gate, the inputs are D1, S2 bar, S1 bar and S0. Third one, it is D2, S2 bar, S1, S0 bar. So in this way, last one, the inputs are D7, S2, S1 and S0. So all these outputs, they are given as the inputs for the OR gate. So we get the Y as this D0, S2 bar, S1 bar, S0 bar, or D1, S2 bar, S1 bar, S0, or dash dash up to this D7, S2, S1, S0.